Hello friends, very good morning to all of you. So today we are going to discuss PF28 part 5, that is handling secret. So we can just try to understand how we can handle the client secret in the OAuth communication. And once you have this idea, then once we can jump to any grant flow, any grant workflow, whether it's OAuth code or whether it's implicit or ROPC or any other, you can able to understand like how these things are happening there. Okay, so yeah, let's begin and we can discuss more. Discuss handling secrets. So how to handle this client secret, because I think we discussed the browser application, web application, we discussed native application. We haven't seen like this client secret required for the implicit flow. That is true. So if you are using that implicit flow for the browser applications, that is not required. But for the web application and the native application, it required. In native application, we have other option also as a PKC, but we can talk later. But at least we need to understand how to handle this client secret and what is this client secret, right? So let's quickly discuss using this presentation. Okay. So the purpose of the client secret is to let an instance of client software authenticate itself to the AS, to the authorization server, apart from any authorization conferred to it by the resource owner. The client secret is not available to the resource owner or the browser, allowing it to uniquely identify the client software application. Okay. Client secrets are configuration time secrets because they represent the client software itself and are configured into the client software. So the client secrets are configuration time secrets because they represent the client software itself and are configured into the client software also. That's why we can say this as a configuration time secrets. Access token, refresh token, and authorization codes. Authorization code is the exchange that I talked about in the previous session, that you can receive from the PingFederate authorization server, and then you can use that to get an access token. So the access token, refresh token, and the authorization codes are all runtime secrets because they are stored by the client software after it is deployed and running. Runtime secrets still need to be stored securely and protected appropriately, but they are designed to be easily revocable and auditable. Right? That's basically, it's not like fixed, right? You're changing that, right? After 60 minutes, your token expired, you're getting a new token, but definitely you need to secure it properly also, but it's a kind of revocable and auditable, not like the configuration time secret. Client secrets is not changing like that. Yeah. Okay, so configuration time secrets in contrast are generally things that are not expected to change often. That is true. Client secrets we are not changing often, right? It's maybe if required we can reset that, but it's having some expiry time like 1 year like that. Okay, so it's not expected to change often. That's why, it's that's why it's represent the client software itself and are configured into the client software. In OAuth 2.0, this dichotomy is addressed by removing the requirement for all clients to have a client secret, and instead of defining two classes of clients, that's public client and the confidential client, based on their ability to keep a configuration time secret. Okay, so what is public and confidential? So public client, as the name suggests, are unable to hold configuration time secret. Okay, that unable to hold, that means unable to store or unable to keep it secret. Okay, that's the client secret we are talking here, and therefore have no client secret. This is usually because the code for the client is exposed to the end user in some fashion, either by being downloaded and executed in a browser or by executing natively on the user device. Consequently, most browser applications and many native applications are public clients. Okay, so these browser applications or these native applications are not able to hold that configuration time secret, or you can say the client secret. That's why it's not recommended to use this OAuth code flow where the client ID and secret is required. Okay, so we need to plan some alternative, so we can discuss quickly in this after this slide. Okay, so in either case, each copy of the client software is identical and there are potentially many instances of it. The user of any instance, we are talking here about the public client only. Okay, just think about browser application or the native applications. So in either case, each copy of the client software is identical and there are potentially many instances of it. The user of any instance could extract the configuration information for that instance, including any configured client ID and client secret, Although all instances share the same client ID, this does not cause a problem because the client ID is not intended to be a secret value. Okay, anyone basically attempting to impersonate this client by copying its client ID will still need to use its redirect URIs and bound by other measures, right? If someone can able to impersonate, you have some other measures also that is talking here. Having an additional client secret in this case does no good because it could be extracted and copied along with the client ID. It's a public client, right? So it can be extracted the secret value along with the client ID. That's why this auth code flow is not recommended for the public clients, that is basically native application and the browser based applications. Okay. Yeah, and then the potential mitigation, then what are the option you have? So that's why we talk about the PKC. So the potential mitigation is available for application that use the authorization code flow in the form of PKC, that is proof key for code exchange. This protocol extension allows a client to more tightly bind its initial request to the authorization code that it receives, but without using a client secret or equivalent. So we can understand more on the PKC workflow and how it basically like bind that initial request to the authorization code that it receives without using a client secret or equivalent, right? So we can understand more, and that's where native and browser application can go for the PKC, not authorization code flow. Now, if we talk about the confidential client, the confidential clients are able to hold configuration time secret, that is, they are able to hold the client secret. Each instance of the client software has a distinct configuration, including its client ID and secret, and these values are difficult to extract by end users. A web application is the most common type of confidential client. Okay, the web application, as it represents a single instance running on a web server that can handle multiple resource owner with a single OAuth client. That means multiple resource owner is trying to access. Okay, so basically that's why it mentioned a web application is the most common type of confidential client, as it represents a single instance running on web server that can handle multiple resource owners, right, with a single OAuth client. So OAuth client is only single, but you have the multiple resource owner. The client ID can be gathered as it is exposed through the web browser. So you can able to gather the client ID because it's basically it's a HTTP redirect call. So you can able to see in the browser, but the client secret is passed only in the back channel communication, as we discussed. That's a direct call. So you're not able to, that secret is not exposed in the browser. So you're not able to get that value. That's where this communication makes secure. So that's why for the confidential client, we can just go for the auth code flow, because there we have the combination of front channel, back channel, and where we are passing the secret, it's a back channel communication. Okay. So an alternative approach to this problem is also you can use dynamic client registration. So using this dynamic client registration, an instance of a piece of client software can register itself at runtime. This effectively turns that would otherwise need to be configuration time secret into a runtime secret, allowing a higher level of security and functionality to clients that would otherwise be unable to use it. Right. So you can go for the other option. You have the dynamic client registration. That is basically at the runtime only, your software can register that. The client software basically I'm saying. So effectively this turns like need to be configuration time secret into a runtime secret. So it's just adding a higher level of security and functionality to clients that would otherwise be unable to use it. Okay, so you have this option also, dynamic client registration, but yeah, you can go for the PKC flow also. And your PKC flow, I'm talking about that like native browser based application where no need to use the client secret. And for the confidential client, you can, as a web application example, you can go for the auth code flow where you have the combination of these two communication and where your communication is secure, and yeah, it's basically secure as you have the secret you're passing through the back channel communication, not the front channel. Okay, so this is about handling secret. You have the public client, you have the confidential client. How to deal with these two clients, you understand, right? So public client, you can go for the PKC, and for the confidential client, you can just directly go with the auth code flow. Okay, so this is about handling client secret. We can now, let's jump to the grant, different grants, because we already talked more thing about these grants, but we are really not currently able to understand the complete workflow. I think you have some idea right now as we talk in the code, as we talk in these sessions, but let's try to understand how exactly the workflow is working. Let's understand the workflow of authorization code and the PKC first, and then we can just configure some client, we can register some client in PingFederate with that flow, with the auth code flow, and then we can test in the Postman to see how the things are working. Okay, so yeah, let's jump to that. And if you have any question, please put in the comment section. Okay, thank you.